Hello everyone, this is Dr. Nimish Kumar Srivastava, Assistant Professor in AKGEC Engineering College in the Department of Electronics and Communication Engineering. So in this video lecture series of digital communications, we are dealing with the, digital electronics, we are basically dealing with the complex topics. What are the different complex topics? We have choose those complex topics. The student is finding some problem related to these topics. So we are going to handle those topics selectively. So in our last video, we have seen the latches. What is latch? It's a cross-coupled device. So in that case, we have discussed about the SR latch, how we can coin the name of S and R to two terminals of SR latch. So we have discussed all the basic concepts related to the latches. So in this video, we are going to discuss about the flip-flop. What is the problem that is associated with the latch, because of which there was a need to develop another kind of a combinational circuit, sequential circuit that is called as a flip-flop. The only difference between a latch and a flip-flop is based upon the triggering. In the latch we don't have any clock pulse, whereas in the case of a flip-flop we are having clock pulse. So that clock pulse, why we require that clock pulse? Suppose that we are having a 3 latch. So if we are using that latch for as an example for traffic signal. So what is happening in the traffic signals? We are seeing some kind of numbering that is displayed on the screen of the traffic light, and based upon that numbers, either the red will glow or green or yellow. So based upon that counting, like if there is a counting of 80-second delay, and after that there will a switch from one light to the another light. So the problem, what is the problem that might arise in the latch is that delay. If suppose we are counting the numbers like 9 to 8 or 9 to 7. So this is the number that will move one by one, and it will move till 0. As an example we are taking. So what will happen to 9? It will be 1001 in binary, and in 8 it will be 1000. Similarly, for 7 it will be 0111, and for 3 2 1 it will be 0011, 0010, and finally for 1 it will be 0001, and at the 0 it will be entire 4 bits are 0. So this is what we are expecting. The person who is just standing at the zebra crossing, he is just waiting for the proper numbering. So this is one by one, it will move from 9 to 0. But what will happen if suddenly instead of moving from 3 to 2, is suppose that due to some circuit delay, instead of changing this bit changing from 1 to 0, if suppose that this bit doesn't change from 1 to 0 and it remain as it is for 1. So what will be the count at present? It will be 0 0 1 1. So instead of moving from 3 to 2, it is again showing 3. So that means there is some circuitry problem available with the latch. That means there is no proper synchronizations, because of which all the 4 latches doesn't respond at the same time. So that is the problem which arises because of the improper synchronization. So we need another kind of sequential circuit which have a proper synchronization for the changing the sequence. So that is the need, that is why we are having a flip-flops. So that flip-flops are used basically for proper synchronization. So what is the problem associated with the latch? So because of which we are having this flip-flops. We are providing clock in flip-flop, for proper synchronization, This is for the proper synchronization. That is the very solution, that is the solution for the latches. So the difference between the latch and a flip-flop, if the question is asked like in your exam, like write a point of difference between the latch and the flip-flop. So the first point of difference will be in terms of a synchronization. So that will, you can write the point in terms of a clock. Means that in the latch there is no clock signal available, whereas in the flip-flop we are having a clock signal for proper synchronization, right? So that means another that the point of difference can be written like latch going to respond for the moment we are applying the inputs when it is enabled, whereas in the case of a flip-flop going to respond only if we are applying a clock signal to that. If we are not applying clock signal, it will hold the past value and it will not respond to whatever the changes that we are making in the input terminal of the flip-flop. So that is the 2 point of difference between the flip-flop and between the latch. Now the next thing is that another point of difference that we can tabulate, we can write in the tabular form is like triggering. What kind of a triggering that is available with the flip-flop and with the latch? So in the case of a flip-flop we are having a edge triggering, whereas in the case of a latch we are having a level triggering. Now the question is what is triggering? So triggering is basically of two types: edge triggering and level triggering. So these are the two possible triggering that can happen in the flip-flop. Now why we require these triggering? We as a human being knows the importance of a time, but the device, the machine like a microprocessor, they don't know what is the they don't know the importance of a time. They will not respond to the input signal or to the command if you are not providing a clock. This is the clock which tells the machine or to a processor that you have to change your state. Like if you are at present 1, change to 0, or if you are at present 0, change to 1, because that machine also understand everything in the form of binaries. So that is the purpose of the triggering. That means a clock are used to tell the processor or to a machine that change your state. If you are not giving a clock, that it will not change its state, it will remain in its past state. So that is the purpose of any clock, that is the purpose of any triggering. That is why we are required triggering. So triggering is of two types: edge triggered and a level triggered. Now what is the meaning of edge triggered and level triggered? Let us try to understand with the help of one figure in terms of a clock pulse. Suppose that I am having this series of clock pulse available to me. Similarly, I will draw the same thing on this side, so that we can easily get the concept of difference between the edge triggering and the level triggering. Now if suppose this edge triggering is also of two types: negative edge triggering and the positive edge triggering. So we will discuss both things one by one. So we are having both types of that means two possibilities available with the edge triggering. First is positive edge triggering and another is a negative edge triggering. So these are two possibilities available with the edge triggering. Now let us take the case one by one, each case one by one. So I am considering positive triggering. What if I am considering positive triggering? So in the case of positive triggering, that is the meaning. Means that your machine or your flip-flop going to respond only if it is seeing a transition from 0 to 1, right? So at the moment of that transition it will respond, while in the remaining state, whether it is 1 or whether it is changing from 1 to 0, that is immaterial for that particular device. That is the meaning of a positive edge triggering. Means that it will respond only at the transition from 0 to 1, at the time where there is a transition from 0 to 1, whereas in the rest case not going to respond. So that means it will respond only at this point, because at this point there is a transition from 0 to 1. And similarly another point of transition is this one. So again it is going to respond, and this will again going to respond. So that means at these three positive edge triggering, your flip flop going to change its state. That is the meaning of positive edge triggering. Next thing is negative edge triggering. So what is happening in the case of negative edge triggering? So in the case of a negative edge triggering, suppose that if I again take this example, so in the case of negative edge triggering, this is 1 0 0 1 0 1. So here there is a negative edge triggering, right? So that what is the meaning of a negative edge triggering is that your flip flop going to respond only at the particular instant at which there is a transition from 1 to 0. That is, instead of a time at which there is a transition from 1 to 0, flip flop going to respond. While in the other case, like when it is making a transition from 0 to 1, it is not going to respond. Similarly, at the 1 level, it is also not going to respond. For that, for the device which is negative edge triggered, it is only interested in seeing a transition from 1 to 0, whereas for a device which is positive edge triggered, it is interested in seeing a transition from 0 to 1. So at its point of interest only it is going to respond, while at the remaining point is not going to respond. That is the main point of a difference between a positive edge triggered as well as the negative edge triggering. Next case is the level triggering. What is level triggering? We have understood what is edge triggering. Edge triggering means whenever a clock, we are applying a clock. So what are the edges? Edges means whenever there is a transition from 0 to 1 or when there is a transition from 1 to 0. That are the edges. While the levels are 0, 1, 0, 1. These are the level. So if your device is level triggered, means that what will the meaning of level triggering? This is the meaning of level triggering. So that means this is 0, this is 1, 0, 1, 0, 1 and again 0, 1. If I am saying that my device is level triggered, so that means its meaning is that it's going to respond only at the level 1. The moment it sees a 1, it will respond. Whereas in the case of edge triggering, it want to see a transition in front of his eye. It want to see a transition from 0 to 1 or 1 to 0. Whereas in the case of a level triggering, the moment it is seeing a value 1, it will respond. And the moment it is seeing a value 0, it will stop responding. That is a point of difference between a level triggering and the edge triggering. Now in the case of a edge triggering, we have seen that flip flops are edge triggered, whereas in the case of a latch, we have seen that it is a level triggered device. So that is the main point of a difference between a latch, a flip flop, as well as what is the meaning of triggering, what are the types of triggering, what are the further categories in which we have divided the edge triggering, so that we have understood very clearly. Now the next thing is, once we have laid down the foundation of triggering, now we can easily understand what is flip flop, what are the types of flip flop. So we will start with the first, that means SR flip flop. SR flip flop using NOR gates. So that is the thing that we want to discuss. Now in the case of a SR latch, we have seen the SR latch using NOR gate. That is something which can be drawn like this. Now last class we have discussed the latch. It is a cross coupled device, so we have to connect it in a cross coupled fashion. So that is the latch, and we are having the inputs, that is your R, we are calling it by RL and SL. Now we have to connect it with the AND gate. Now we are making a provision to provide a clock to the flip-flop, because we know that flip-flop is having a clock. So we are providing a fashion in which a manner in which we can give the clock to this entire flip-flop. So this is our FF, it is a flip-flop, and this is SFF, and this is your clock. So this entire thing is your flip-flop. This is the flip-flop. So internal circuitry will be something like this, and externally it will look like this. There will complete block. One terminal will be R, one terminal will be S, and there will be your main output. Let us call it by name Qn plus 1, and its complemented form Qn plus 1 complement. This is your Qn and this is your Qn complement. So that is the figure for SR flip-flop using NOR latch. Now let us try to understand the working principle with the help of a truth table. So we will draw the truth table. So that means we are having S, we are having S terminal, we are having R terminal, we are having Qn plus 1. Similarly, we are having Qn plus 1 complement, and another possibility is the state in which your flip-flop is. So this is the truth table that we will discuss one by one. We will consider all the 4 combinations and visualize the working of the flip-flop. So let us try to write all the 4 combinations, 1 0 and 1 1. Now let us okay, one mistake that we did here is in terms of clock. So we have to apply the clock also. So we will write the clock and this is your clock, because we have to understand how your flip-flop respond when you're not applying a clock and how it is responding when we are applying a clock. So this is 0, and for remaining 4 we will consider 1. So 0 0, 0 1, 1 0 and 1 1. Now let us try to visualize how it is responding when there is no clock pulse applied, because we have applied a clock in such a manner that when there is no clock pulse applied to the RF flip-flop or SR flip-flop, it doesn't respond to the input changes. Whatever the changes that we are making in the input terminals, it should not respond. So we have to connect the clock in such a manner. So that's why we have connected the clock through the AND circuitry. Whereas we will see that in the case of a SR flip-flop using NAND, we will connect the clock circuitry with the help of a NAND. Now let us try to visualize this point, that what if I am providing a 0. So the moment you are providing a 0, irrespective of the input value RFF and SFF, what is the output that your AND gate will provide? Definitely it will provide 0. And the moment you have provided 0 at the input of the NOR latch, it is not going to respond, or it is not going to respond as per the change. Means that for RL, we have understood in the last class that this NOR latch considering 1 as an input. If it is considering 1 as an input, so for the input 0 0, it is still waiting for the input to be given. So if it is still waiting for the input to be given, means that it will hold the past value. It will not change its past value. So that is the meaning of if we are not applying a clock pulse, and if we are applying a clock pulse, how it's going to respond. The moment you are not giving a clock pulse, you are probably giving a 0. So the result of this AND gate will be 0 0. So your latch going to be in the hold state, means that at the output you will get Qn. So irrespective of the input value, because even if you are providing a 1 1 to R and F terminal and or R and S terminal, or providing 1 0 or providing 0 1, it is immaterial, because one of the input is always at the 0 state, so the product will be 0. So that is the meaning of this AND gate, that is the meaning of this entire fashion in which we have connected the clock circuitry. Now that means for clock 0, immaterial of the whatever the value that your R and S terminals is having, irrespective of those value, your flip-flop in the hold state, means that your Qn plus 1 will be Qn and Qn plus 1 complement will be Qn complement. So it is the hold state. So we have understood the first combination. Now the next, the moment we are applying a clock, how your entire flip-flop circuitry going to respond. So now we will start with the second combination, that is for clock 1 and with the input 0 0, what is the state of the flip-flop. So let us see that combination. So we will first try to erase the past combination. Okay. So with the input 1 and with the input 0 0, what is the output? Again, one of the terminal of the AND gate is 0. The moment one of the input of the AND gate is 0, definitely the output will be 0. So means that this is 0, this is 0. Again your latch is waiting for the input to be given. So it is still in the hold state, holding its past value. So that is the meaning of this, the moment we are applying a clock and still we are providing a 0 0 input, that means your flip-flop will remain in the hold state. And another case was in which you are not applying a clock pulse and immaterial of the values of your input signal, your flip-flop will remain in the hold state. So that means for this case also we are having Qn and Qn complement again in hold state. Now next thing is next combination when your SF is 0. Let us see that combination. SF is 0. SF is 0 and clock is 1. And clock is 1 and RF is also 0. So for this, the moment we are applying 0 to one of the input terminal of the AND gate, definitely the output will be 0, and for this combination 1 1, the output will be 1. Means that SL, that means S terminal of the latch is waiting for the input, whereas RL terminal of the latch got the input. So as we have understood that SR latch using NOR gate, consider 1 as an input. So means that R, that means reset terminal of the reset terminal of the latch got the input, and if it got the input, it will respond as per the input. Means that it will show the output as a 0, because that is a reset terminal. We have provided an input to a reset terminal. That means the output will move to 0. That means Qn plus 1 will be 0. Qn plus 1 will be 0 and Qn plus 1 complement will be 1. So this state is called as reset state. Fine. Now the next combination for 1 0, what will happen if we are providing input to S terminal, input to S terminal. So input is given to S and R is 0. So this will be changing its state from 1 to 0 and it will change its state from 0 to 1. Means that S input of the latch got the value and it will change the state of the flip-flop to a 1. That means it will set the output. So for this we are getting 1 and 0. So this is your set. Now last combination, whenever we are providing both the input as 1 1. So in the case of SR latch, we are providing both the input as 1 1. Let us see how it will respond. So this R is also 1, S is also 1, output will be 1 1, and both the input of the SR latch using NOR gate got the 1 and 1 as an input. So when both the input is triggered at the same time, how your latch going to respond? Because at the same time you are telling the latch to set your value and to reset your value. Is it going to possible? It is totally not possible. It is something like saying that 1 equals to 0, which is totally not possible. So that is a invalid state, because your latch get confused whether it have to reset the value or whether it have to set the value, because at the same time it is getting the input as a 1 1 on the reset terminal, on the set terminal. So as per the values it should reset its value, as per the value it should also set its value. So it will get confused whether I have to produce a 0 input, whether I have to produce a 1 input. So that is called as an invalid state. So this is your invalid state. So this is invalid. So this is the truth table for the SR latch using NOR gate. Similarly, we are going to discuss the truth table for a SR latch using your NAND gate. So let us try to discuss that thing also. Okay. So next topic is SR flip-flop. SR flip-flop using NAND gate. So in the last case we have discussed the SR flip-flop using NOR gate, and in this case we are going to discuss the SR flip-flop using NAND gate. So for this, let us try to first draw the latch, SR flip-flop or SR latch using the NAND gate. So it will be something like this. We have discussed in our last class also. So here it is something like this. So this is the case that we have discussed in our last class also. So now let us see how we are providing the clock. So in the case of a SR flip-flop using NAND, the entire circuitry is going to contain a NAND gate, whereas in the case of SR flip-flop using NOR gate, the only modification is in the way we are providing a clock. In that case we are providing a clock through a AND gate. So that is the some technicality that one have to remember in order to explain the truth table of the SR flip-flop using the NAND as well as using the NOR gate. So in this case we are having, for the NAND we are having SL and RL complement, and this is Qn plus 1, Qn plus 1 complement, and similarly we are having a clock, and on this side we are having flip-flop set terminal, on this side we are having flip-flop reset terminal. This entire circuitry is your SR flip-flop. So this is the entire block diagram. How internally it look like, it's something like this. SR flip-flop using NAND gate. So similarly we have to discuss the truth table also. So we are considering the input terminals, that is SFF, RFF. Similarly we will consider present normal output, present complemented output, and finally state. Have the habit of writing the or drawing the truth table with all the inputs, all the outputs, as well as the states. So on this side we are having clock. So it is 0, 1, 1, 1, 1. This is 0, 0, 0, 1, 1, 0, and 1, 1. Now, in the last case, we have discussed that whenever the clock is not provided to the input of the SR latch using NOR gate, we have seen that immaterial to the values of the input terminals, your flip-flop is not responding, it is holding its past value. Similarly, in this case also we are going to discuss that if we are not applying a clock pulse, how it's going to respond, whether it our concept or the concept that we have built, that concept is still valid at this point or not. We have drawn the circuitry in such a manner that whenever we are not applying a clock pulse, your circuitry should hold its past value. That means it will remain in its hold state, holding its past output. So let us try to apply a clock 0, and let us take an example of applying both the input as 1, 1. What if we are providing both the input as 1, 1? So in this case, whenever you are providing a clock as 0, what will be the output? Output will be 1 and 1. So, but the latch is having a input as SL complement and RL complement, means the active low. So in this case, whenever you are providing a 1 input, your SR latch is designed in such a way that it will assume, or it will take 1 or it will take 0 as an input, because this is active low. So when it is active low, it's going to respond only when it is seeing a 0. Similarly, and this is also active low, so it's going to respond only when it is seeing a 0. So, but at this time of instant, we are providing 1, 1. So it is still waiting for the input to be given, means that it will hold its past value. So that means your flip-flop for the clock 0 remain in the hold state. So let us try to write the value. So that means for irrespective of the input terminals values, your output Qn plus 1 is Qn and Qn plus 1 complement is Qn complement. So means that it is in the hold state. Similarly, for the clock input and the input combination as 0, 0, let us see how your flip-flop respond. Both the input, entire input is, this is 1, this is 0, and this is also 0. Again, the moment we are seeing a 0 for the NAND gate, definitely the output will be 1. So for this case also we are getting 1, 1. Still the same condition. Still your latch is waiting for the input to be given, means that it will hold its past value. So it will remain in the hold state. So this is also again hold. Now let us take another combination, that means 0, 1, when your reset is 1. So let us see when your reset is 1, reset is 1 and set is 0. So in this case, the moment we are seeing one, 1 to the both terminal of the NAND gate, it will produce an output 0. And here we are getting 1 input as 0, so definitely the output will be 1. So means that for this combination of 0, 1, your one of the input, that is a reset input of the latch, got the value of 0. So it will respond. So what is the meaning of R? It is reset. As per its value, it should reset the output, means that output should be at present 0. So that is the meaning. That means Qn plus 1 will be 0. Qn plus 1 will be 0 and this Qn plus 1 complement will be 1. So it will be reset. Reset. Now another possibility, like what if we are giving F, that means S terminal input as 1 and R as 0. S as 1 and R as 0. So for this it will be 1, for this it will be 0. Now as per this combination, your S bar has got the value 0. So as per its meaning, it should set the output value, means that Qn plus 1 will be 1. So that means Qn plus 1 is 1, Qn plus 1 complement is 0. This is your set state. Now for the input 1 1, how your flip flop respond for the input 1 1. With the input 1 1, output will be 0 0. That means both the terminal of the latch got the input at the same time. Means that at the same time you are telling the latch to enter into a set, at the same time you are telling a latch to enter into reset. Will it going to possible? How can it set its value and again reset its value at the same instant of a time? That means this is invalid state. So this is your invalid state. Right? So with the manipulation, with the ways in which we are providing a clock, we have designed a concrete circuitry for the flip-flop. Like in the case of latch, we have designed a circuitry in which one of the latch using NOR gate was having S and R as the input, whereas in the case of another, for NAND latch, it is having S complement and R complement as an input. So we want to design a certain a solid circuitry in which both the terminal should be responding for the active high signal. So we have provided, or we have connected a circuitry in such a manner. So let us try to first conclude based upon the input circuitry, like for the SR flip flop using NAND and NOR. So that was the circuitry. This is your clock and this is your SL complement, RL complement, at the same time SFF, RFF, and at this point we are having using NOR, so it will be clock connected with the NAND gate. This is my clock and this is my NAND latch. So this is my, this is your NOR latch. So as we are discussing for the NOR latch, so we have to draw the NOR circuitry. So it will be something like this. So this is my Qn plus 1, Qn plus 1 complement, and this is my flip-flop circuitry. So this is my RL, this is my SL, and this is my RFF, and this is my SFF. So with this circuitry, we are getting, with the both circuitry, we are getting the same truth table. We are getting the same truth table, and that truth table is, we are having S flip-flop RF terminal, we are having Qn plus 1, we are having Qn plus 1 complement. Similarly, we are having state. So that means when also we are having a clock. So if we are providing a clock, not providing a clock, immaterial to that, this is 0 0 0 1 1 1, and based upon this it is Qn, this is also Qn, this is your reset, so it will be 0 1 1 0, and finally 1 1. It will be 1, it will be invalid state. So it is Qn complement, Qn complement, this will be 1, this will be 0, this will be, and this is your hold state, hold, and this is your reset state, reset, set, and invalid. So that is the point of a conclusion for the SR flip-flop using NAND as well as the NOR gate. So in our next lecture video, we will discuss about some more concept related to these circuitry. So thank you all.